Hi, welcome back. So we continue our discussions on algebraic expressions. So in past videos we discussed about the polynomials. How do we classify polynomials based on the degree of polynomials and based on the number of terms of polynomials. Then we also discussed about how do we solve the polynomials. So what we discussed in the previous video was that to solve the polynomials, what we do is that we combine like terms. Remember we used the example of houses and cars. Houses, yeah, let's use the operation here, arithmetic operation here. Houses and cars. So we have say 6 houses and then 3 houses and then say maybe 3 cars. So total it becomes 9 houses plus 3 cars. The arithmetic operation between house and car really don't matter much because houses and cars cannot be combined together, cannot be added together because they are different terms. Now, so what now we are going to do is that we are going to use our old arithmetic concept which we have all learned in past of distributive property. Distributive property. Now this is something which we are going to use a lot in solving most of the algebraic questions. Now what this says is that if say a term A gets multiplied by x plus y, then this gets multiplied by this and also this gets multiplied by this term. So it becomes A into x plus A into y. So when we open this parenthesis, these brackets, the term outside gets multiplied by both the terms. Now we'll just extend this further, then we'll take a couple of examples. Now say we have got two different terms within brackets, A plus B, and it is getting multiplied by x plus y. Now understand the term which is there in the parentheses, in the brackets, we consider it as one term. So for us this is one term initially and this is one term. So when we open this bracket, now because x and y are not getting added, when we open this bracket what happens is that this gets multiplied with this and then this gets multiplied with this. So I'll first take an example which we have already done in past in previous classes and then I'll come and solve this for you. Say we had 3 plus 5 getting multiplied by 4 plus 2. So what actually we do is, again applying this kind of this property, distributive property, this 3 plus 5 actually gets multiplied by 4. This whole gets multiplied by 4 and then 3 plus 5 gets multiplied by the other term 2. Subsequently this gets multiplied by 2. So coming back to our example, A plus B multiplied by x plus y. Now this first this a plus b will get multiplied by x, and then this whole a plus b will get multiplied by y. So this becomes equal to a plus b, let's put dot here as x, as multiplication sign, x plus a plus b into y. Now to solve it further, again the same distributive property will apply second time. So this x now will first get multiplied by this, and subsequently this will get multiplied by this term. Similarly, y will first get multiplied by this, then it will get multiplied by b. So what will become now? A into x plus b into x plus a into y plus b into y. Now, when we have applied the distributive property here, after that to solve, what we'll do is that we will just combine the like terms and solve it the way we had solved earlier. So let's quickly take a couple of examples. We'll start with slightly easy one and then we'll try to move to little complex ones. Okay, so let's put it example number, let's take a better color. Yeah, the brighter the better. Say it is 7. So when there is no operator or there is no sign, it means it's a multiplication sign. X plus x raised to power 3 minus 4x raised to power 3 minus x plus 1 plus 4 into x raised to power 2 minus 2x raised to power 3 plus 7. Now, initially it looks that it's pretty painful to solve or pretty difficult to solve, but mind you, it's a very easy question. It's one of the easier problems which I have taken. So what we'll do first, we'll first apply distributive property here. So remember the BODMAS rule, BODMAS or BEDMAS, whatever you call. So first we solve the brackets. So to solve the bracket, we have to open the brackets and we have to apply distributive property here and here. Understand this 4, remember this 4 is multiplied by this whatever value is there in the, or expression is there in these parentheses. So as per BODMAS rule, we'll first open the bracket here and multiply 4 with this and then we'll add. Come on, let's see. So when we open this bracket, it becomes 7x plus 7x raised to power 3 minus, again, so ideally, you know, the way I used to do it, I used to first write all the leftover terms. So I'll actually show you that how I used to do. Yeah. So I used to first write the leftover term because there are times when you get so involved in solving brackets that you forget these terms. Here in any case the terms are in the middle, so it becomes still easy to, you know, remember that you have to solve with this, then you have to bring it down this, and then you have to solve this. But there are times when you get so much involved in solving this that you forget these terms. So it's a good practice that you first write the leftover terms. Okay. So these are the leftover terms which I have written. Now solving this bracket, it becomes 7x plus 7x cube. Here this 4 gets multiplied by each of these terms, so it becomes 4x square minus 8 x cube plus 4 into 7, 28. Now what we do is that as a next step, we just bring down the like terms. So I'll just use different color for different terms. So let's first bring the terms of highest degree together, which are 7x cube minus 4x cube minus 8x cube. Then we'll write the terms of second highest degree, that is degree 2. And here we have got 4x square. Now we'll bring the terms of x, 7x minus x. Minus x. And then we have got constants left. So what are our constants? Plus 1, this, plus 28. Now first we applied the distributive property. In fact, we applied the distributive property twice, first here and second here. Then we just brought the like terms. We combined the like terms or brought the like terms together. Now it's pretty simple for us to solve. So what we do is that when we solve this, we straightway write x cube and then we apply arithmetic operation on these coefficients. So it's minus 8 minus 4 minus 12 plus 7, it becomes minus 5x cube plus 4x square. So there is no other x term in x square, so we'll just write 4x square and then we'll solve this. Plus 7x minus x is plus 6x plus 29. This is our answer. So the term which was looking so difficult to solve or was looking pretty confusing, it actually can be solved in just 2 steps. So let's take one more example. So we'll take couple of more examples so that the entire concept becomes pretty clear to you. Say it is a raised to the power 3 into a square plus a plus 5 plus a gets multiplied by a raised to the power 4 plus 3a square plus 4 plus 1. Again, very simple. What we do is that we multiply this a raised to the power 3 with each and every term and solve the bracket. Similarly here, we multiply the a with this, and with this. And then what we'll do is that we'll just bring the like terms together and solve the equation. So let's do it. Cool. So it is, yeah, this is good. Oops. A raised to the power 3 into a raised to the power 2 plus a raised to the power 3 into a plus a raised to the power 3 into 5. So one bracket we have opened. Let's open the other bracket. So a into a raised to the power 4 plus a into 3a raised to the power 2 plus a into 4 plus 1. Now let's first see, let's first solve this further. Now when the bases are same, so here base is A and base is A and they are getting multiplied. So what will happen to their powers? Their power will add up. Remember this we have already done in when we were doing the squares and cubes. So it is A raised to power 3 plus 2. Now this is a redundant step which I am doing, but I'm doing it just for the sake of those students who may not remember that concept or may not have done that concept. So again, the bases are same, the powers will add up. So here it is raised to power 3 and here it is, when there is nothing, then it means it's raised to power 1. So it becomes A raised to power 3 plus 1 plus it is 5A cube plus, let's take yellow color, yeah, again it is A raised to power 1 plus 4 plus it is 3 into A raised to power 1 plus 2. So what we have done is that we have brought since these are getting multiplied, so this coefficient of 3 will also get multiplied by this. So we can write 3 before the variable part, the way we are writing it here, like 4A plus 1. Now it is A raised to power 5 plus A raised to power 4 plus 5 A raised to power 3. So finally we have solved this bracket. Here it becomes A raised to power 5 plus 3 A raised to power 3 plus 4A plus 1. I should have used different color, but anyways, it's okay. Okay, so what are we now going to do? We are going to bring the like terms together. So what are the like terms? So first we'll start with the terms with highest degree. So what is the term with the highest degree? Here it's A raised to power 5, A raised to power 5. So let's write A raised to power 5. In fact, you can again solve it directly from here. But again, I am writing it one more step just for your better understanding. Then what is the next highest degree term? It is A raised to power 4. Let's use a different color. A raised to power 4. Then next we have got two terms of degree 3. What degree I said? Degree 3. So which are plus 5 A raised to power 3 plus 3 A raised to power 3. Now we are left with what? We are left with this 4A plus left with 1. Now it's simple. Like terms we have combined together. So what we'll do is that we'll just write those terms and add or subtract whatever operation we have to apply on their coefficients. So it becomes A raised to power 5, 1 plus 1 becomes 2, plus A raised to power 4, plus 5 plus 3, 8, 8 A raised to power 3, plus 4A plus 1. So this solves our polynomial or expression. Now we will take one more example, where we are going to multiply polynomial with a polynomial. So here what we are going to take is that we will take an example of say uh, x plus x square multiplied by, what do you do? 1 plus x minus x minus 1 multiplied x minus 1 multiplied with 1 plus x square. Let's try and see. So first this entire bracket will multiply with 1 and this entire bracket will multiply with x. Similarly, we'll multiply entire bracket with 1 and entire bracket with x square plus x square. So we are just multiplying with 1 plus x plus x square multiplied with x minus 1 multiplied with x square. Okay, so this x plus x square comes as it is here. Now this x will get multiplied by this and this x will get multiplied by x square. So it becomes plus x. When we say x into x, it becomes x square, and x square into x, it becomes x cube or x raised to power 3. So we have solved this. Now let's solve the other part. Minus, let us not open the bracket right now. We'll do one more step. Minus. We are not opening the bracket because we just want to retain this negative sign. We'll open this bracket in the next step. X into x, it becomes x square and then x square into minus 1 becomes, x into x becomes x cube. X square into x becomes x cube minus x square. Now quickly let's review how many terms we have got. 1, 2, 3, 4, 5, 6, 7, 8. So when it gets multiplied by this one term, this two terms. One term, two terms. When we multiply this with 1, we get one term. When we multiply this whole bracket with this, it becomes two terms. So this is how you can actually count and see whether you have missed out something or not. So here we are going to get two terms. There already the two terms were there. So we've got two terms. Then again this comes here and then we were supposed to get two terms here which we have got here. So we have not missed out on anything. So now let's open the whatever brackets which we have. So it becomes x plus x square plus x square plus x cube minus of x, and this minus will make this minus plus 1 minus x raised to power 3 plus x raised to power 2. Now we'll combine the like terms or bring the like terms together. So what we'll do is that we'll write in the descending order of their degrees. Okay, let's see, I think something will get cancelled here. Yeah, this x raised to power 3 will get cancelled with x raised to power 3. So this makes the job a little easier. Also, this x will get cancelled with this x. So now we are left with what? We are left with this x square, this x square, and this x square. So it becomes x raised to power 2 plus x raised to power 2 plus x raised to power 2 and this one constant. And this will be equal to 3x square plus 1. So the expression which looked pretty complex, the answer was so simple. And we could have actually solved it in just 2 steps. So just to recapitulate what we have discussed here is, what we have discussed is the distributive property. What is that? When we, so when we have got something outside of this parenthesis or bracket, and when we open this bracket, we multiply each and every term with the value or expression in the other bracket. So for example, when it was a into x plus y, it was a got multiplied by x and then a got multiplied by y. And when we had a polynomial getting multiplied by polynomial, so first we'll multiply the entire bracket with one term, first term, then the entire bracket with second term. And if in case there was a third term, we have multiplied the entire bracket with third term as well. So here we have applied distributive property twice, here we have applied distributive property once. And then we'll combine the like terms together and solve it like any other arithmetic operation. Oops. That will work. It worked. Good. So this brings us to the end of this video of solving the polynomials or algebraic expressions. Now in next video we are going to do very interesting topic, that is special multiples of binomials. So and that will actually make our main base for our major topic, that is quadratic equation, which we are going to start after 2 more videos. Till then, thank you.